This is Peter and Stan. They will be talking about Microsoft Office file format sorcery, and stage is yours, guys.
Thank you, Flo.
Thank you.
Good morning, everyone. It's a real pleasure to be here, troopers. My name is Stan. This is Peter, he's my colleague. And we're both red teamers at a small and dedicated company in the Netherlands called Outflank. And we are going to take you into the world of Microsoft Office today. What we see in the wild is that MS Office macros are one of the most important methods for gaining an entry for actual attackers. So that is why we as red teamers also need to employ those methods. And as both static and dynamic analysis measures on macros are getting stronger and stronger, this requires offensive research in order to be able to bypass those measures. So that is what we'll be doing today. The first part will be on static analysis. That will be me doing that, and then we'll switch to Peter, who's going into bypassing dynamic analysis. For static analysis, to start, we have to start with the boring part, which is a primer on what kind of file formats are actually being used in Microsoft Office. And we won't go too deep into this because it's really boring. But one of the most important mechanisms that's being used in Microsoft Office is the so-called compound file binary format, or simply called compound files, OLE compound files. There are different names for that. Who of you are familiar with this file format? Can I see some hands, please? That's a few. That's a good start. So basically what the CFBF format is, it's like a file system in a single file. So there's the concept of like directories and files within a single file, but then they're called storages for directories and streams for files. And this format is used heavily in Microsoft Office. Actually, up to 2003, all doc and XLS files, they were all in this format. But even nowadays, some parts in the newer zip and XML-based format that's used from 2007 and up, there are still parts within that zip file that are the CFBF format. Most important one is the file vba-project.bin, which actually contains macros from 2007 and up. But we'll see more of that later. I wouldn't really recommend reading this document because it's quite boring, 46 pages, and there's a lot of references to other standards there. But there is a lot of fun to get out of it. So a little bit more on this file format. What does it look like? If you open it in a compound file editor like this one, this is my personal favorite, FlexHex, it just looks like this. I'll switch to an interactive view. So I say, I have a file here, I can open it, open as a compound file, and you just see containers and streams with information. That's basically how it works. If you would open a newer zip and XML-based file from Word, then the contents would look like this. And if you go into the Word directory, there's this file called vba-project.bin. And that vba-project.bin file is actually a compound file again, which is exactly like what is shown in the previous slide, but then only the macros container and its contents. Short introduction. So what is in this vba-project.bin? What is there? To work with that, you can do that via the GUI. I've shown you my favorite tool, FlexHex, but there you might also want to automate working with this file type. There's different directions that you could go there. Most important ones are OLE file, which is from Philip Lajadek, author of OLE tools, OLE VBA. That has really limited options for writing, so that's mostly for defensive analysis. There's the native iStorage interface from Microsoft, which only works on Windows, so no real cross-platform stuff that you can do there. And then there's my favorite one, thanks to Nick from Silent Break to Security for pointing this one out to me, which is OpenMCDF, which is a .NET framework which allows you to work with this file type. And it also runs on Mono, which means that therefore it's cross-platform. And we'll be using that heavily in the coming demos. So then to macros. So macros are stored within this CFBF file format, and there's another specification for how macros are stored within this file format. That's even more pages, 109 pages of complexity. Various parts are still undocumented, Microsoft doesn't always stick to their own specifications, and that's actually where the fun starts. We'll get to that in a few minutes. And part of this specification heavily relies on another implementation, another standard, which is about compression. So there's this custom compression algorithm that's all over the file contents of macros. And we'll also get to that in a minute. As I promised, this was the boring part. So a little bit on the different streams that are in this file. So there's the macros container. The macros container contains two streams, project and project WM. It contains another container called VBA, and that one also contains several streams in this case. Let's start with the project stream. The project stream, it actually contains project information, and what it does is just instruct the VBA editor GUI. That's what it does. The VBA project stream within the VBA container, that contains project information, but that one instructs the VBA engine. So not the GUI, but the actual engine that's going to run the macro. And there is actually no serious official documentation on what's in this file. But it is really important in execution of macros. Then there's the dir stream, and the dir stream is just basically a project layout, a directory layout. This whole stream is completely compressed. Whereas for the next stream that we're going to look at, a module stream, the module stream contains the actual code, amongst others. And in this case, only the code is compressed. Rest of this is not compressed and partly documented, smiley face. Again, if it's not documented, it's going to be fun. We'll get there in a minute as well. So, phew, that was a few minutes for the boring part. Now it's time for abuse, for the fun stuff. And for the fun stuff, we are going to work with one of the most obviously malicious macros. We're going to switch to Cobalt Strike in our case. Let's see, where did I hide it? I think I hid it right here. Yeah. So this is Cobalt Strike, red teaming tool. And one of the basic things that you can do is just create a really, really, really basic Office macro. Office macro. Copy to clipboard. Let's put it in a Word document. Not in the normal dot module. So this is the default Cobalt Strike macro. It's a really obviously malicious macro. What it does is just it kicks off run DLL, and through process injection via Windows API calls, it creates a RWX memory block, inserts shellcode there, and then creates a thread in run DLL to kick off that shellcode. Obviously malicious, a really basic macro, and as we can see, if we upload this file to VirusTotal, we have 34 out of 60 detections. And basically all the major vendors, of course, detect such a macro. Easy stuff. So then one of the first tricks that we are going to apply is to hide our macro from the GUI. And therefore we go to the project stream. And the project stream, as I said, is just a GUI instruction stream. It's like a text file. It's not compressed, only ASCII characters, and actually there's just lines with CRLF ends for each line. And what we can simply do is instruct the lines that tell the GUI that there is actually a VBA module in our file. And now we are going to switch to code. So we're going to use the OpenMCDF framework to actually parse a file from a non-Windows system. So this is OS X, parsing the Windows file and doing this manipulation. So if I say I copy my original file to hidden.doc, and I then say evil office minus, I'll show the help file, minus G for GUI hide on CS hidden. Yep, now it's done, and we switch back here. Don't save. There should be a file called CS hidden. There's CS hidden. So indeed, there's a macro in here. I can execute it. If I execute it, I should be seeing a new beacon connection indeed coming in at Cobalt Strike. But if I now go to the GUI, there is no macro anymore. It's completely hidden. But this is just GUI stuff. On a file system level, for sure, the macro is still there. So if I use Philips Ole VBA, then I see that the macro is, of course, still in the file. It's just simply not hidden in the GUI. So let's go back to the file format, back to FlexHex, and look at what this module stream actually looks like. It looks like this. The first part is, well, we get to that later. And then somewhere exactly here starts the compressed macro code. So this is a custom compression mechanism. And the way that I know that is because there's a O1 here, which means that here the compression starts. This is an instruction that compression starts. So what if we would just add another O1 to the end of the stream and save this file? So any parser that would parse a Office file and just search for the last part of the file where the compression starts would now find this O1, and let's see what then happens. I've prepared this file on disk already, I guess. Yeah, so I'm doing Ole VBA, CSO1. Then probably I should save it. Original, yeah, that's fine. I'm going to save this. Yep. Ole VBA.
Original, yeah, that's the other file.
Oh, sorry. Yeah, thanks. That's the problem with live demos. And now, all of a sudden, Ole VBA crashes. There's a patch coming anytime soon. But this is Ole VBA. Let's go back to VirusTotal. If we upload this file, so we had 34 detections. We now lost 5. You might think that that's no biggie. But let's see which one we have actually lost at the moment. Amongst them, there's Endgame, and there's Sentinel-1, like 2 really big EDR vendors that fall for this really simple stuff. But even VirusTotal itself has a problem in parsing this. Because if we go to details on the original file, you clearly see that it is being able to analyze the macro, and that we can see the macro source code in here. But if we go to the stream with 0.1 edit, and we go to details, then suddenly VirusTotal is not being able to parse this anymore. So really, really, really basic trick. But there's much more fun stuff. Sorry for switching out screens, guys. So that's basic. But what if we wanted to completely remove VBA? It's not even there. Then let's go back to the specification. And this is a module stream, so this is where the stream that holds the code. And it consists of 2 parts, a performance cache and compressed source code. Well, compressed source code I've just explained, starting with a 1 and then a compression of just basically the VBA text that you see in an editor. The performance cache, what the heck is that? A really vague sentence that's here. There's no additional explanation except from this vague sentence, and it says, must be ignored on read. Well, I promise you, Office is not ignoring this on read. This is where they're deviating from their own specs. Yeah. So what is this performance cache? Well, if you save a file in Microsoft Office, every module stream has a performance cache. As I said, there's no official documentation, and this performance cache, it contains pseudocode, which is called P-code, which is pseudocode like compiled code for a VBA stack machine. And the stack machine is VBA version specific, but the VBA version hasn't changed in the last few Office releases. So everything from 2010 onwards will work just fine. And the P-code is executed if the version of the file matches the version of the host, like Word or Excel that's running. And it then completely ignores the VBA macro and it runs the P-code instead. This has been explored from a defensive perspective, most importantly by Dr. Bonchev, but also by the team from Walmart, who have released several tools. The website is at vbastomp.com. But this hasn't been properly explored and weaponized from an offensive perspective. So that is what we are going to do. Yes, okay, yeah. So this is what we are going to do. I'm going to do this slide, that slide first. So what it will look at to know if the version of Office matches the version of the file is in the VBA project stream, and there is a version byte there, and it says must be ignored on read, must be FF on write. So let's look at what is actually in there when I press save. AFOO. So, sorry Microsoft, but oh, there it was. You're simply not telling the truth in this case. There's more happening. So what we have to do is we just have to match the VBA project version, and then we can completely disregard the VBA code and the P code is being executed instead. So we can also do that via code. So back to here. What I'm now going to do is I say I am going to run evil office. Again, sorry, I'm first going to copy my original file, which has a 1. I don't think that that's dangerous. But just to make sure, I'm going to copy my really original file. Yep. To cspcode.doc. Evil office, GUI hide, and I'm going to stomp it with fake code. Okay, so if I now run a code analysis tool on this, like Ole VBA, on P code, it will say, well, this is the code. Sub fake code with high troopers, this is fake, this code is fake. But if I actually go to the file, P code, that's the thing with live demos. Yep, there's macros in here, enable content. And again, we have a second malware connection coming in. So it's not the fake code that was being ran, it was the P code that was being ran. So if we make sure that the file matches the Office version, then VBA code is disregarded completely and another type of code is being executed. So how can we extract P code from files? There's a tool called pcodump, which is from Dr. Bonchev, and I'll just demo it here, pcodump on this file. And then pcodump is still able to actually parse the P code, and we can see here what kind of malicious actions that it is doing. So how can we get rid of analysis by tools like this, pcodump? For that, we dive back into the specifications again. And if you look at the dir stream, which is like the directory layout, and there's a specification, and there's a stream name and a stream name Unicode. So there's two fields pointing to the same module. One is in ASCII and one is in Unicode. So we have two names for the same object. What could possibly go wrong here? And this is like all over the specification, this kind of stuff. Well, it's actually pretty simple. Almost all analyst tools use this name. Microsoft Office uses this name. So what we can now do is just say, so we have our file. I'm going to copy the original file. Where was it? Copy temp original to random. And I'm going to say evil office. All of this is the same, but I'm now going to set random names for the ASCII names of modules in the dir stream. So what we can now see, if I open random, it's getting slower and slower, of course. Enable content. And we have a third connection coming in, so the macro is still working. But if we now do a P code analysis, Okay, this is really, really, really interesting. I have it in examples. All of a sudden you see error file not found. So analyst tools are using one specification, Microsoft itself is using another part of the specification, and there we get complete mismatches. So then the last question is, how do we match the target Office version when we are going to weaponize this? Well, fortunately, Office itself tells you which exact version that it is. And you can get that exact version by using document templates. So what you can do is you can just create an empty document, completely empty, connect a template, and a template can be on a website. So you can just point it to a website, which can be HTTPS. It can be any extension, so it doesn't have to be .dot or .m for a template. It can be lolcats.jpg, you can point it to there. And upon retrieval, Microsoft Office actually sends its detailed version there. And from our tool, it looks like this. It looks like this. So we have our evil Office running. Actually, Office sends a few bogus versions first. I'm not sure why that happens, but it's pretty clear if you've seen a lot of it, that this is the actual header that you should trigger on. And we see here that this is Office 16, which is 2016, which is a 32-bit process, and we have every information that we need here. And we then know, okay, so let's start serving a VBA project stream, which matches the 2016-86 version. We will release a short table of Office versions and which bytes should be included in VBA project. And actually, this code will be released in a couple of weeks. Currently, it's a really ugly proof of concept, and I don't really feel, I would be ashamed if I would publish the code at this moment, but wait a few weeks and you'll see it arrive on our blog and on GitHub in more polished code. So then, in the end, the question is, like, how effective is this? So we've gone from 34 detections on a really basic and clearly malicious macro back to 29. And if we scan for the P-code version, all major antivirus engines are completely gone. So P-code, from an offensive perspective, is a really interesting area to abuse, because currently it's passing all major static analysis analyzers that are here. We only have an hour for this, and Peter is really anxious getting to the more dynamic part. There's plenty of more tricks like this, but they all follow a simple recipe, which is the following one. So there's much more evil, and if you follow this recipe, it's a guaranteed success. First thing that you should look for is abuse ambiguity in the specs. I've shown you the example of a field in ASCII and a field in Unicode, those pointing to the same object. That's just asking for problems, and there's plenty of those in the specifications. Another guarantee for success is to explore undocumented features. If you just open up the 109 pages specification and you just do Control F, start searching for must be ignored and must not be present. Because clearly they aren't ignored by Microsoft Office, and they are almost always present if you just save a file from Microsoft Office. Really interesting. And the last one is just try deviating from the specs. It turns out that Microsoft Office is pretty robust if you don't follow the exact specs, while most analyst tools, Picodump, OliVBA, VirusTotal, and practically every tool that I tested, they are much more sticking to the actual specs, and you just crash if you deviate from that. So this recipe guarantees success. We've only shown you the tip of the iceberg. And the funny thing is, in this talk we have only explored the MS OVBA specification, like the way in which macros are stored. But if you go one layer deeper to the actual compound file binary format, and the specifications there, I'm pretty sure that you can apply the same recipe and end up with even more interesting stuff, or shit, or however you want to call it. So that concludes the first part. We've shown you how to evade static analysis in a few simple ways. By just slightly deviating from the standards, adding a 01 byte, we already fool a few major engines. But if we go to P-code, a completely undocumented feature in Microsoft Office, then we can evade all major antivirus engines using a really basic macro like the default Cobalt Strike one. But if you hit a properly configured Microsoft Office instance on a updated Windows 10 machine, then there's also dynamic analysis involved. Most importantly, MZ for VBA. And that is exactly what Peter is going to tell you all about.
Hopefully we'll switching screen. Yeah, so that worked. Thanks for the demo guards and for the changing of screen guards. Indeed, talking about escaping the chains enforced by MZ for VBA. So in September 2018, Microsoft announced that there will be an MZ implementation in Office. What MZ is it's an interface for a lot of the scripting engines supported by Microsoft, so PowerShell, C scripts, and they all send their commands to this MZ interface. This MZ interface dispatches it to the antivirus engine. The antivirus engine sees the commands being executed and can give its results back to MZ saying block this file or proceed. For Office, Microsoft made a bit of a different implementation than they did for the other languages. So what they came up with was this picture. So they have this behavior log, which is stored within Office, which is not sent to MZ. And this behavior log would contain any COM method or Win32 API call. So starting run DLL, messing with memory, these kind of things are all in this behavior log. And then they have trigger events saying, well, these specific Win32 API calls or these specific events from COM, they should be in a trigger, and only then this full behavior log is sent to this MZ engine. So this was announced in September, which means it then gets into the monthly release, and as of January, this is in the semi-annual release, which most Office 365 users have. So if you're targeting a user which runs Office 365, Windows 10, this feature is in place, and the the antivirus engines, Windows Defender can pick it up and see stuff on the macros being executed. So let's first build an environment so that we can kind of troubleshoot this. So our first step was to build our own antivirus engine. So hooking into MZ, being an antivirus engine, and it was really troublesome. Tried to make a DLL, didn't work out. Turns out it's much easier. You can enable MZ logging with a couple of PowerShell lines with the ETW tracing. So that will generate the MZ events and will just store them in your event log. This is a system-wide setting. Any MZ event, PowerShell, whatever, it's all then in this MZ operational event log. And then the data is just in this event log, and then you have a rather small script to parse this one out. So this all seemed relatively simple. I took this couple of lines from manifestation, and I created a file. I created a new file, subtest shell calc.exe. Hit F5, nothing happened. I looked into my MZ operational log. There are all kind of PowerShell stuff coming by. I looked into my versions. It was the version which was supposed to be. What happened? Well, MZ doesn't work on VBA code on a new file. So, and there are more of these kind of edge cases. So anytime you want to test and play around with MZ, make sure that you save the file, reopen Word, because then you're certain that it's really processing the file that you're kind of intending. So these are like small things. Took a lot of time to debug and troubleshoot what was going on. So how does it look? Let me see. So this is the Windows event log. There are these events in this MZ operational folder now, and in the details you'll see PowerShell logs for now. And if I go into this demo, open this demo file, and I enable content, I will certainly get calc. Yes, there's my calc. Then in the event log, we can refresh. We see there's this one new Office VBA event. That event contains the contents of the file name and the content that was being sent, which is just a byte array. So this is kind of what the antivirus engine gets. What the content of that byte array is actually, in this case, it's a kernel virtual alloc call, a virtual protect call, and a calc call. And what's interesting here, I just made, so I'll also show you the macro, which is running here. Let me make it bigger. So what my, let me zoom in a bit. So this is just a bit of random test code. So I did I do a virtual alloc, just allocate memory. I play around with RWX bytes on that memory just for fun, and then I run calc. And what we already see is that there's only one event in this event log generated, which means that, and in that event, the last entry was calc, which means that the other two are like, they were not trigger events. So virtual alloc or virtual protect, these are not like the trigger events, only this shell calc was a trigger event in this MG engine, and then it provided its full behavioral log, so all the events before that, it provided to the engine. So that was kind of the first step into troubleshooting and getting this stuff to work. Yeah, so this is what I just showed. There's a couple of lines of PowerShell. It's really dirty, so if he says cleaning up code, I'll publish it, but it will be really dirty, so big warning there. But at least it can help you in troubleshooting this. So the first bypass approach is trust me. And if you looked into that picture of how MZ worked, well, there was no mentioning of trust, but what is trust actually in the office context? Well, MZ and trust have a relation. So the MZ engine can be configured which files it should process. So you can say, well, I want all files always to be executed, or you can have the default value, which says, well, we wanted to have all the files except the files that are on a trusted location, files that are trusted documents, files that are digitally assigned, let's skip them. And this is the default, and Microsoft is saying, well, this is for performance reasons, where I think, why are there performance reasons? A legit macro will probably never do like shell calls, so how often will it happen? But this is Microsoft's design decision. So there are 3 values for this macro runtime setting, which is just a registry setting in a current user registry. If you don't set it, it will be on this middle value, and it will just ignore certain classes of files. Well, what can go wrong there? So how does Office work with trust? So we have this macro setting, this main macro setting. Disable all macros, disable macros with warning, meaning the user just needs to click, allow all. Then we have trusted documents. This is used to determine whether a file, you already approved a file. So if you open a macro enable document once, it will set something in the registry, and that way it will know the next time you open the file that you don't have to click the nagging yellow bar again. Then there are trusted locations. They are folders where you typically store like templates or your normal dots and they are automatically approved. And it should be noted that even with this macro security high setting, disable all macros without notification, it does not disable all macros. Trusted docs, and trusted locations can override that. So there is some vagueness in what you think what would mean disable all macros, because it's not meaning all macros. So first thing we can do, if we can find a trusted location, we can just have a very simple macro which drops. So this one drops itself in a trusted location, and it does that by just doing save as, which is not a com method, which is not a Win32 method. It's just the default with the word feature save as, saving into a trusted location, and then opening itself. And by doing that, it suddenly loads a macro from a trusted location, and suddenly MZ is completely blind. So this is just some simple proof of concept So the first line says, well, this is the auto-open event. This is an event which always fires if you open a document, like open a docx file or docm file. And it says, well, just now save myself into this app data roaming templates directory, which is the default trusted location. And then save myself back into the original location. And then the last line says, well, create a new file and have it be inspired on this template, which is in this trusted location. And upon creating a new file, with a template, another event is called, which is called the auto new event. So it's a new file based on this template, and that's where we drop our malicious code. So this was a very simple way to bypass MC by just having misconfigurations in trusted locations. You can already abuse it, and MC suddenly is blind. I'll show it. I just popped calc a second time, and I only still have this one event from this first demo I did. But I don't have any MC events for this second calc popping. I'll now clean my event logs, so the next demos will all be clean. So this was simple stuff, but there are some cons. So do we have a writable location where we can write? Can we do this maybe even with trusted documents? And this again is, well, I was already looking into trust records actually, because I was looking at it from a more defensive perspective, but so this is kind of how Microsoft stores trust in a trusted document. This trust record is a registry key, and it has the file name, and it has stores some attributes in a D-word. To create a timestamp, just 3 random values. I don't know what they are, but they're not a hash. And then this FF7F, which means it's approved. So how does it affect MC? Whatever I do in my lab machine, trusted documents are still passing through MC. I really don't know what's going on. Either Microsoft messed up their documentation, or really it's an idiot error on my end. But whatever I do, trusted documents still go through MC. So I really have no idea what happens here. That doesn't mean that trusted documents are not interesting, so I'll just make a small sidestep to stuff I did there. So these D-words contain three kind of fields: this create, date, this random stuff, and this approval on the end. Well, it works if we just add zeros in the middle part, so we can just skip that one. So we now know that there is no integrity checking on trusted documents. So if someone at one point in time approved a file, if we can write something on disk with the same location and the same create time, then interesting opportunities exist, because the user once approved a certain macro, and we can just add different code. You could even do this on the network. If you can do this on, if people in a company are having legit docm files or legit macros on the network, we can try to use this create timestamp and abuse it. We just timestamp, and that's sufficient. So more interesting is that if we can predict this timestamp, we may have a way to bypass even future security controls a company may implement. So we may have long-term persistence, because trust records overrule this macro security high. So can we predict this timestamp? Well, that's very hard, but there are some nice tricks around that. So it is very hard to predict this exact timestamp, but these word templates are very versatile. And as Stan explained, you can set them to internet locations. So if we have a doc file with a template reference, which is just an HTTP or HTTPS URL, we can see what Word does with the trust record, and then we see, well, what's the create time of a file which lives on the internet? Microsoft, Windows doesn't know. It will just give it a C time of 0. So if I, for example, on my machine would once be able to set this registry setting, so this is where my malicious file would be, just a random URL where I will later post my payload, and just this value with only zeros and a couple of Fs on the end, then the only thing I need to do, if I ever want to go back into that company, I want to get network access back,
I just sent a docx file to a user, and without any macro warnings, we already have code execution. So this is not an MZ bypass because trusted records don't work with MZ in my setup, but this is long-term persistence by just using this small registry hive, which is normally used for maintaining which files are already approved. So back to MZ, because this was just a small sidestep. So in the original picture of how MZ works, we have these two different things. We have the behavioral log, which is filled with all the COM events, and we have trigger events. So there's a question whether there are code execution opportunities which are in this behavior log, but are never triggering the real MZ event. So they're not calling the MZ engines. They may be in the log of the bird macro, but if it's not sent to MZ, the antivirus engine has no chance to detect. And, well, I can invent them myself, but I just started looking around what's available there, and then I knew of a couple of nice attack surface reduction bypasses by Dark Operator. And, well, what they, for example, do is, this is starting with WMI, starting a process with WMI, and in the end, the method being called is called spawn instance. And this spawn instance event, it just doesn't show up in the MZ log. So here again, we have our calc. And we have again, this is the read empty, we have an empty MZ log. So this is again a bypass by using methods which Microsoft didn't implement a trigger event. So if we would extend this macro by doing a shell command afterwards, we would see that this is still in the behavior log, but it's just not triggering MZ. So far, I've seen the trigger events mainly on things like shell execute, all methods with these kind of words in it, and a lot of other stuff is being missed. The same holds for if you start saying, well, in Word, let's raise an instance of Excel, and in Excel do a DDE execute, a DDE initialize. It's also blind, so that's another method where MZ will just be bypassed by COM functions, which Microsoft has deemed we will log, but we consider them innocent or non-triggerable events. So this is like the second approach of bypassing this MZ implementation. We just need to find a lot of methods where which are not triggered. And then there's the third one. Well, it logs COM, it logs Win32 API calls, but there are ways to execute code without any of those. And they're mainly like built-in features of Word, or they're like more like tricks. So one of them is Excel4 macros. So there's this legacy Excel format, or Excel4 macro format, which is nothing to do with VBA. Yesterday I learned it was implemented in Excel.exe, so it's really within Excel. And you need to learn a little bit of different language, but within VBA you can call such a method. And this method is not a COM method, not a Win32 API method, so this is just not within this MZ behavior log. So execute Excel4 macro, and then within that macro exec calc. It will work, it will just show you, again, nothing. Where is it? So there's again calc. More than sufficient calcs in my live demos, I would say. Other tricks, and now we're moving into more dirty tricks, and this is actually the most lame MZ ASR bypass I have ever developed, and I'm really proud of the lameness of it. I hope it works. It's always a bit, this is like really challenging the demo gods. So with send keys, you can send keys. You can't send a Windows button, but there is another button, which is your shortcut for the Windows button, which is like escape space or something. If you do that, it just starts up the start menu and it starts calc. You can do this to start PowerShell with a full command line as well. There's some timing, sometimes it goes wrong, sometimes it goes right.
It's really in your face. It's very dirty. But if you want to do this as an attacker, you may distract stuff and show screens and blue screen on the background with pictures or whatever. It's just a very lame MZ and attack surface reduction bypass because calc is now not started by Excel. This is just the Windows operating system starting calc or any other program you want. Yeah, so it's Control Escape is actually the shortcut for the Windows button. I didn't know it anymore. So it's also not MZ'd. And then the third approach is just to disable MZ. So MZ is stored in our current user registry hive. Can we influence that hive without code execution? Yes, we can. We just drop it in the startup directory. We drop a reg key and a regedit command, or like a startup.bat file in the startup file. So just a bat file. And the nice thing is, well, we have Word at our disposal because we're doing this all within Word mostly. And in Word we can just say, well, just create a new file, have it the following contents, so like with the following registry contents. Save this file, name it import disable mz.reg. Make it a file format.txt, do the same for a bat file, and then we just run this, drop this in the startup directory, and voila, either we disable mz, or we create new trusted locations where we drop our real payload, and in the same bat file we can of course also say start our payload, which gives us, if we have write access into this startup directory, it nicely gives us an opportunity to disable mz altogether. And this is really hard for Microsoft to patch because this is just Word saving text files. So how will they ever, they won't be able to hook this up into MZ saying, well, the save as event should now be within this list of behavior log of MZ. So this is, again, in the area of lame as ways around MZ. And so if we look into MZ, there are a lot of lame as ways around it. If you compare it to like the PowerShell versions that the bypasses are way harder to find. This is all still, by design, a bit weak, I believe. Microsoft really didn't do their best, in my view, in how this is architectured. It's not very robust. A lot of bypass techniques, so with trusted locations, with COM, functions that don't trigger, and functions that are not COM. There's still stuff where I am puzzled, so I don't believe the Microsoft specs on MZ and trusted documents. What's happening if a file is a new file on my computer? Why is it then suddenly not in MZ? I don't know. As a side effect, I found this trust tracker stuff where we can create long-term persistence, bypass any higher erased macro security settings on the long run by just doing this with templates. And I invite all of you to enjoy this ride, and there's a lot more stuff to be found in this MZ implementation and a lot more bypasses. I'm wondering whether Microsoft will do anything on this. I didn't discuss it with them because I believe all this behavior is according to specs. So their specs say that they do this, well, that's what they do. We'll see how they will evolve this in the future. I think it's really more like a beta than like a full-featured MZ implementation on Office. So that concludes our talk. And we have a couple of minutes left for questions.
No questions? All questions answered? Oh, perfect. 2 questions. I start here. That's okay for you?
So I'm just thinking, you looked here at Word and Excel. Is this also applicable to PowerPoint? I mean, it's just, I'm just thinking, if I open a Word document with a macro, even from a friend, it's kind of weird. If I open Excel, a bit less weird. But, you know, which other applications, is this attack surface actually huger, or?
The attack surface is bigger. So if you look at the static part, then storing macros is quite the same in PowerPoint. There's some small differences there, but there's a lot of similarities. For MZ in PowerPoint, I'm actually not aware. Does it hook?
I would say it hooks the engine, but I haven't tested the other products because I think there are more VBA-aware products. Like AutoCAD is also doing VBA or did in the past. So
So we really have just scratched the surface. There's many more things to explore. We focused on especially Word and a little bit of Excel, but indeed there's PowerPoint, there's OneNote, there's Access, there's many applications that could also be interesting from this perspective. Yeah.
I look forward to seeing more results. Thank you.
Thanks.
Are there any challenges to the AV vendors scanning for the P code? I mean, you said right now they're bypassing them, but is there anything that like fundamentally prevents them from just figuring that part out?
Yeah, lack of specification. That is really an issue. So Microsoft actually says in their specification, this should be ignored. Well, they don't do that themselves. So, and if there's no documentation on what's not there officially. So there's Dr. Bonchev, which is really a AV guru, which has been in that field for decades, and he has written this P code dump proof of concept. He's completely reverse engineered the most important stuff there. I think that has been hours and hours of hard work that he has put into that. But getting this completely right without a specification, that's very much error prone, as I've just shown you. If you just slightly deviate from the specs, such a scanner would already crash.
one addition on that one is the P code stuff does get processed by MZ. So the AV engine could see it if they would hook into MZ. So to really do this properly, you need to kind of combine the two approaches.
More questions?
Thank you, guys.
All right, thank you very much.